Hello, everyone. Welcome after the lunch. I hope you had very nice lunch. My name is Tushar. I work for Siemens Research, Bangalore, India. I do stuff very related to technical debts, refactoring, design smell, and anything and everything related to software design and architecture. In this session, I am posing a question to you. Does your design smell? And in order for you to answer this question, you need to know what design smells are possible in your design, and how can you detect it, and whether, and then only you can answer this. So I'll be talking about design smells with some examples. And hopefully after this session, you'll be able to answer this question. So let's start. Grady Booch. Who doesn't know Grady Booch? He's the co-inventor of UML, wrote many books, and currently he is an IBM fellow. In fact, many of his books are still used in software engineering courses, bachelor level and master's level. He has written foreword for our book, and this text is taken from our book, foreword from that he has wrote. In this foreword, he is comparing cities with software. He says cities grow and they evolve, and we need to renew them to meet the need of the populace. In the same way, software also evolve, change with the time, and we need to refactor it, renew it, to meet the need of the requirement, context, depending on the context and the customers and other stakeholders. I like this metaphor a lot. So I would like to use this metaphor as a theme for this session. So let's start. I'll be talking about Bangalore because I live in Bangalore, currently known as Bengaluru. Some 20 years back, the city used to know, people used to know Bangalore as a pensioner's paradise. Because after people retired, they used to buy a nice bungalow with their pension fund, and then they just settled there. And the weather was really nice. In fact, it's nice, but that time it was even nicer. But then IT revolution happened, and the city grows very drastically. With time, a lot of development happened in Bangalore. You can see a lot of highways and new roads came up. Metro came up. Obviously, IT parks. We are talking about Bangalore, we don't mention IT parks. That's almost impossible. And obviously, residential complexes. But this is a very positive side of the city. With growth, a lot of problems also occurred. So let's take a look at that side also. This is the map map of the locality where presently I live, somewhere here. And I would like you to take you through a journey from my home to my office. And during this journey, what I observe, I would present to you. This is my place where I live presently, and this is approximately 200-meter stretch. When I shifted there 2.5 years back, that time there used to be a very nicely laid road, which is connecting this place to this outer ring road. With time, due to rain, due to non-maintenance, And due to heavy trucks, because some construction work is going on here, that road is gone now, and it looks like this. The road should be there, but road is missing. Okay, so after some struggle, I come out from this place to this service lane, and I go a little ahead, and then I need to take this U-turn. There is an overbridge here. Here there is an overbridge, and I need to take the U-turn under the bridge. And when authorities built that bridge, that time they thought this is very narrow junction, narrow lane, so let's not put the traffic signal. So they didn't put the traffic signal. So what happened? Now, if there is no traffic signal, everyone wants to go first, like this. The discipline is missing, which means access is unrestricted. To give you a real picture, this is what happened. And by the way, if you want to follow rule, if you are a very nice citizen and if you want to follow rule, then you will stuck there forever, because nobody will let you go through. So you have to be part of the system. So you have to, flow in that with the crowd. So after some struggle, I come out and I take this U-turn, come out on this outer ring road, and then I go a little ahead, and after a kilometer or so, I reach here. This is a very big junction. So I need to go straight, but since it's a junction, I need to wait here. Interesting thing about this junction is there are 8 legitimate turns you can make from this point. And now imagine rest of the 8 points also you can take 8 turns. And I'm only talking about legitimate turns. So what it means is 8 multiplied by 9, 72 permutations of turns possible from this direction. And I'm only talking about this direction. The same 72 turns possible from this direction also. So what it means is on this junction, 144 different permutations are possible. And obviously, if you wait for, say, half an hour or so, you'll see more than that, because people may violate other rules. So this looks like a hub to me. And what is the problem with hub? A hub is a single point of failure. And that's what precisely happened some time back when a big truck broke down here in the middle of the road, and traffic stuck from all directions. And it took hours to clean that traffic. Then the next observation, I come a little ahead, and then I see what I see, more traffic, not surprisingly. And some people, some smart people, or probably pseudo-smart people, they adopt hacks, something like this. They are probably in hurry, so they just bypass this traffic. And obviously, footpath is not a road. Footpath is for pedestrians. Footpath is not a road. Similarly, there are many big circular, open, this kind of structures also in Bangalore, where similar to this kind of a deadlock also happens. So what happens is this guy is waiting for this guy is waiting for this guy is waiting for this guy, and this guy again waiting for this guy, which means I'm waiting for myself. It's a deadlock. Obviously, it's a deadlock. Somebody has to break that deadlock. It's a cycle. Again, in this case, the person who's driving, first of all, he's not wearing helmet. Then he's talking on phone. He's multitasking. He's a smart person. And studies and research says that women are much more smarter multitasker than men. What it means is, here is the proof. So she's doing one more extra thing than this person. Do you observe something like that here also? I'm sure you should. You might be facing something or observing something very similar. Yeah. Or something like this. These signboards are not giving me any information. These are noise. Although I'm taking all the examples, I'm quoting Bangalore, but I'm sure that you might have also seen one or another cases. But this is very Indian. This is an electrical pole. Even if you are a very qualified professional electrical engineer, you can't debug this. If some problems occurs in this, then that's gone case. You cannot correct that problem. The only person who can correct this is the local electrician who is working for this local electrical pole for so many years. He only understands how to fix the problem. So the underlying problem is so complex. Not everyone can fix if any problems arise in such a case. And what about this? In India, normally the bikes are designed with very low power, 100 cc to 150 cc maximum. I mean, usually. Obviously, there are some bikes which are much more highly powered, but the normal people use in this range, and only 2 people are allowed actually. And you can count here, 7 people are riding a single bike. But let me ask you this: why I'm talking to you traffic problems? I'm talking to you because I want to point out a observation that every engineering discipline has to deal with non-optimal and suboptimal solutions. Every engineering discipline. And these non-optimal and suboptimal solutions, they violate fundamental principles of that discipline. And these are nothing but smells. And since we are talking about software design, let's talk about design smells. So this is how we define design smells. Design smells are certain structures in the design that indicate violation of fundamental design principles and negatively impact design quality. 2 characteristics are really important here to note: violation of fundamental design principles and negatively impact design quality. If any structure have these characteristics, which means it's a smell, design smell. Now let's connect all the dots. The first problem we were discussing some time back was missing road. If we are talking about a transport domain, then if a road is like an abstraction, and if a road is not there, which means abstraction is missing. The same case we can say in software design also. If you are using clumps of data or an encoded string, instead of creating a proper abstraction, then the abstraction is missing. And what clumps of data means, I mean, a group of data members that you are using together, passing together, processing together. An encoded string means a string is not a simple string. It's containing a lot of information. Let's take an example to understand it better. How many people are from Java background here? Okay, but that's great, but to understand this, it's not required to be a Java programmer. This is Throwable class in JDK, and this has a method called print stack trace. And what this method does, it prints the exception information, for example, where it occurred, file name and method name and other information on a standard error console. And if you are writing a Java application and probably enterprise application, then you need to probably parse that information because it's too much information stuffed in a single string. So you need to parse, probably use regex, and you just parse the information, and then you probably log it somewhere. And now assume if Oracle changes the syntax of this string, what will happen? The program will break. And since it's a public API, there might be thousands of programs that might be using this method, which means all those programs that are using this, the output of this method, all those programs will break. Oracle identified this problem very early on, and they refactored it in Java 1.4. And how they did it, they introduced another method called getStackTrace and an abstraction, very importantly, an abstraction called stackTraceElement. This abstraction has get file name, line number, and all those methods that you may require. Now you need not worry about the format of the string. Whatever the format of the string, you just don't bother about it because you have this stackTraceElement abstraction. You just use the methods that those are provided in this, and you are done. Let's talk about the next problem, unrestricted access. It's very similar to deficient encapsulation. And this smell occurs when the declared accessibility of your data members or even any members is more than required. Point class in JDK, it has two data members, X and Y. And it has getters and setters for this also, get X, get Y, and set location, which is not shown here. Okay, it's shown here. Okay, sorry. So this X and Y is declared public. So what it means is there are multiple ways to access X and Y, which is not actually required. They could have done X and Y private or protected. And this is just a very simple example. There are more than 500 classes in JDK 7 with at least one public field, and 96 classes with 5 public fields. Next problem, hub-like road where there are 144 permutations of turns are possible. So this is very easy actually. You can also map it. This is it's very similar to hub-like modularization. And this smell occurs when the fan-in and fan-out of an abstraction is very high. And what is fan in and fan out? Incoming dependencies and outgoing dependencies. Let's take an example. Component class. This component class is a really beautiful class. It has more than 10,000 lines of code. By the way, let me ask you a question. Who has seen the biggest class, biggest number of lines, highest number of lines in a single class? Okay, let me ask you it this way. How many people have seen a class with more than 5,000 lines of code? Okay, there are many hands. Keep your hand, in the raised condition, because I'm going to refine the question. Now, 10,000 lines of code. There are still a couple of hands. 15,000 lines of code. 2. Let me ask you, how many lines you have seen, sir?
80,000.
80?
Yeah.
Oh my God.
I have a pretty class, and it was C project.
God bless you, sir.
Originally migrated to C++.
How many have you seen? 25,000. Okay, you. I think you and your team require this.
Thank you.
Please take a look. Hopefully, it will help you in this refactoring process. Okay, coming back to this discussion. So this component class have approximately 500 incoming dependencies and 71 outgoing dependencies. Fan in and fan out is really high, and that's why it's a hub-like modularization. But let me ask you a question. Why, even if the fan in and fan out is high, what is the big deal here? Why we should be worried about this? We should be worried about this because if any one of these, if component class is changing, then you need to worry about these 500 classes, whether you need to change them or not. In the same way, if any one of these 71 classes are changing, then you need to worry whether you need to change component or not, right? And that's why it's a big deal. That's why it's a smell. The next one, footpath is not a road. Now let me say in this way, if you have two abstractions, road and footpath, can you design like this, that your road is a superclass and footpath is your subclass? Can you design like this? You cannot, because footpath is not a road, and whenever you design a hierarchy, is-a relationship must be preserved. And whenever is-a relationship is not followed in a hierarchy, then the hierarchy is broken. That's precisely a broken hierarchy design smell. Example, very popular one, vector and stack. Vector is the subclass, vector is a superclass and stack is a subclass. And obviously stack is not a vector, that's why it's a smell. But again, let me go in little detail. Why it's a big problem? It's a big problem because vector is a random data structure and stack is a LIFO, last in, first out, which means that you can access vector in any order, just you need to provide an index. But you cannot, the same protocol doesn't apply to stack. But since they are in the same hierarchy, now assume this, if you have a stack object with you, then you can access all the methods provided by vector, which means that you can, with the stack object, you can access any element in the list, which means the semantics of an abstraction, this abstraction is broken. And that's why it's a big problem, and that's why it's a smell. This should be very easy. Can somebody guess? Cyclically dependent modularization. When two or more abstractions depend on each other directly or indirectly, they are forming a cycle, then it's a cyclically dependent modularization. These 6 abstractions from Java again, they form multiple cycles actually. Here you can see date and time zone, they depend on each other. Date and calendar also depend on each other, and so on. The problem with the cyclic dependent modularization is all the participating abstractions have to be used together, understood together, even tested together. And that increases the cognitive load on the developer. And apart from that, the cyclic dependency create a lot of problems in build process and things like that. So multitasking. And here, when I say multitasking, I don't mean multi-threaded programs or any parallelism is bad. That's not what my intent is. What I want to say here is that the responsibility of an abstraction should be single. If an abstraction is realizing more than one responsibility, then it's a multifaceted abstraction. It's a violation of single responsibility principle. Let's consider an example. Image class have 4 tasks: load, process, render, and store. You may say that everything is related with image, so it's okay to keep everything in an image class. But that's not always true. You need to see the responsibilities, and you need to see how many reasons are there for them to change, for this abstraction to change. If there are multiple reasons to change, then which means that this class is realizing multiple responsibilities. At the same time, granularity of responsibility is also important. You cannot say that since my application is an image processing application, so I can put all the source code in a single class. That's not, the responsibility is not really granular in that case. So you need to break down the responsibility in a proper way. And by the way, when we say responsibility always measure in terms of axis of change. Okay. Useless signboards, it can be mapped to unnecessary abstraction. Those abstractions, those are not really required, and we could have avoided it, but they are somehow introduced in the software design. Consider this example. So there are basically 4 constants you are declaring in a class. By the way, it's not a class, it's an interface. That's even bad. Interfaces are not for declaring constants. And these 4, the language provides a lot of other methods to realize the same thing in a different way, much more efficient way. Why a person should be using interfaces to store the constants? This is probably unnecessary. Beyond capacity, when it can be mapped to insufficient modularization. What it means is this abstraction, whenever an abstraction can be broken down and to more modular abstractions, then we say that it's not sufficiently modularized. And there is another reason for insufficient modularization to happen, which is complexity. If a complexity of a method or a class is too high, that also indicates that the abstraction can be further decomposed. So this is what I just said, that there are, let's see the examples. So socket permission class get mask. CC in the sense cyclomatic complexity is 81. In the morning, just before this session, Ellen was talking about cyclomatic complexity, and he was saying that you need to worry if cyclomatic complexity is crossing 4. 5 is a very alarming thing. And look at this, 81. And again, component class, this class has 259 public methods. And JTable has 203 methods. These abstractions can be broken down further. That's why they are suffering from this smell, insufficient modularization. So what is the message that I would like to pass here? That every engineering discipline has to deal with non-optimal and suboptimal solutions, and software engineering is not an exception. In fact, it is much more prone to such smells because the environment is changing. The requirements are changing. We live in a very fragile environment, all software developers and software companies. So the one key message that I would like you to take from this session is that design smells are very relevant and important for everyone who cares about the software system. We need to know about them. We need to try to avoid them. And if they are there in the system and in your code, then you need to refactor them. And I have one more book to give. Let me ask you a question. How many people follow refactoring and do carry out refactoring periodically? How many people carry out refactoring periodically? I mean, they practice refactoring basically. Refactoring could be anything. It could be as simple as renaming your variable to maybe go up to architectural level refactoring. It can be anything. So if you are following any of these, then please raise your hands. It's too many. I don't have. I have only one piece. So let me refine the question then. Who's the age-wise, the youngest person who has raised their hands? It's tricky, right? Everyone is younger. Below 20, how many people are there? Below 20? Okay, below 25? Let's come over. Sir, can you please pass this? So the next question is, now at least some level of awareness and some level of knowledge about design smell, you know about them, that at least what they are and what kind of smell that can you may have. And we have we have a classification of design smell in which we have 25 design smells, and this is the classification of all the smells that we figured out and we documented. And I have a couple of posters here. So after the session, I'm keeping it here. So if you are interested to take a look at this classification, please feel free to take the one copy, okay? I don't have, I think maybe 10 or 15 copies only I have. Please feel free to take. So the next question is, since you know about design smells now, the next question is how to detect them. So there are a couple of tools available, but I will talk only about 2 tools. The first one is Infusion. This tool works for C, C++, and Java, and it provides nice visualization and provide a lot of things. For example, there are some metrics it computes, and a nice visualization. You can go in little detail, and the smells also are reported in fashion like complexity, encapsulation, coupling, and things like that. And each smell you can go in little detail that why this smell is occurring and where it's occurring. Another tool is Designite. This is for C#, and maybe I have this video. Oops, sorry. I have this video. Maybe yeah. So it's a very short video. So this is just to show you how it works. You can select your solution file and just say open, and it will show you all the projects. You can select whatever project you want to analyze. You can select all the projects also, and it will analyze all the projects, selected projects. And it will give you something like this. So some key figures you can see here, and then it will show you some graphs. In the left-hand side, metric violation it's showing, and in the right-hand side, detected smells it's showing. And project-specific key figures it's reporting here. Then if you want to go in little detail, then it shows metrics and design smells. So class-level metrics also it shows. So it shows, a couple of class metrics. So you can take a look at this, and you can also sort also. In the same way, abstract design smells are also classified based on the principle. By the way, this tool uses our classification that we proposed. So you can click on any one of the smell reported, and the help of that smell will appear here. Cause of the smell is also reported here. So you got the idea, right? Let's move on. So all the examples and all the definitions I have taken from this book. I'm one of the co-authors of this book. And more information about design smell, if you are really interested, you can go there, designsmells.com. There are many articles and resources available for free to download and use. These are my contact details. Feel free to be in touch. And if you want to know more about design smell and how to refactor them, tomorrow I'm taking a workshop. So you are invited in that. And now if you have any question, I will be happy to answer those questions. Yeah.
What's the difference between this and Visual Studio analysis?
No, I didn't get you.
What's the difference between design tonight and Visual Studio code analysis tools?
Okay, Visual Studio, in my opinion, Visual Studio only provides a maintainability index and a couple of metric information, at least so far. Maybe in 2015 there might be more things coming up. But the design smells specifically, Visual Studio is not detecting. Maybe Visual Studio might be detecting some metrics, but not specifically smells. These tools specifically detect which smell we are talking about. Any other question if you have, please ask. We have a lot of time.
Is there a particular hierarchy of smelling the different components
Mm-hmm.
in a particular troublesome project?
I didn't get your question.
Yeah, is there any particular hierarchy of design smells?
Okay, hierarchy. Okay, maybe severity-wise, you mean? Not right now available. There is no right now available, readily available something which I can give it to you. But yes, you are right. Some smells are much more severe than the others. For example, unnecessary abstraction. It's a smell. It increases your effort because it's increasing the noise. But it's not really very severe smell. When compared to if you have a really large class or a multifaceted class, then it's much more, those kind of problems are much more severe than unnecessary abstractions. Any other question? Which smell?
Do you have statistics on which of these code smells are the most common?
Okay, let me give you some background behind our work because that will answer your question. 3 or 3.5 years back when we started, we used to do a lot of design and architecture assessment. So we knew about smell, the smell, code smell, but it was really generic term, and all types of smells are there. Some smells are really at the implementation level, some are design level, some are even architectural level also. So, and there is no single catalog available when we were, I'm talking about 3.5 years back. That time, nothing was available. In some pockets, many people have worked on that. So some information is available here, 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 but not a single comprehensive catalog available that time. And another problem is everyone is defining smell in their own way. Even if you just take very popular one, God class smell, there are at least 3 or 4 different ways people have defined it. Some people say that if it's a big class, it's a God class. Some says it's the dependencies are high, then it's a God class. Some say if it knows a lot, then it's a God class. So there is not a single definition that we found. So what we did, so we collected all the papers, all the books related to this, and collected all the smell database. So that was approximately 500, more than 500 smells that we collected. Design smells only I'm talking about. I'm not talking about implementation level and architecture level smells. But 500 smell, how you comprehend. So then what we did, then we reduced our scope. We said we will be only looking for design smells, and those are structural in nature. So we looked only for structural smells. And then it reduced to some 252 approximately. And even 250 smells, how can you document 250 smells? Then we started grouping and then tried to classify them. Then we came up with that, let me show you, where is that? Yeah. So then we come up with the first classification that was published in Journal of Object Technology in 2013. That was accepted in 2012. and came out in public in 2013. That time, the editors of that journal said that, why don't you write a book on this? So that time we thought, okay, I think this is the good idea to go ahead with the book. And then with this, then we refined it further, and then we clubbed a couple of smells, we split a couple of smells, and then we come up with the proper classification and proper definitions, and then we found examples mostly from Java and JDK, and then this is how the whole work came up. So this is the background story of this work. Any other question you have? Yeah. Yeah. No, both tools are unfortunately paid tools. But I think a free version is available for some limited time. In fact, the Infusion, the first tool that I was talking about, it's free for if you are analyzing a certain smaller projects, then you can still analyze, you can use it for even, I think, unlimited time. But the other one, the Design Night, I think, if I'm not wrong, then I think 15 days trial is available. But I think that's not really an expensive tool, the other one. The first one, Infusion, is quite a little expensive one. If you don't have any question, then we'll close this session. Yeah, please. Just a moment, just. Yeah. Please be louder. I'm not.
Sorry. In the hierarchy,
Uh-huh.
nothing obviously about implementation inheritance. Do you not see it as a smell?
Hierarchy has the smell. I didn't get you. Maybe I'll come down.
Just asking about implementation inheritance.
Okay. 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 See, if whenever the implementation inheritance, I don't think it's a good idea. Why it's not a good idea? Because there is a different way to realize the same thing in much better way. Whenever there is a principle also that says that use delegation over inheritance. So if you want to reuse, then only for the sake of reuse, you don't create hierarchy. Okay, so that's what precisely happened in that case, vector and stack. People, the developer thought that, all the methods that I need, or many of those methods that I need, are there already available implemented in vector. So why don't I just inherit and then use those methods? So that's a implementation, way, but that's not the right way to use the implementation. So delegation probably would have been the better way in that case. So don't use hierarchy for the sake of reuse.
It doesn't appear to be listed in the smells.
Okay. Okay, thank you.